This video will focus on introducing the concept of limiting reactant, which is part of these two learning targets. Both I can calculate the amount of product produced if the starting amounts of the reactants are known, as well as I can determine the limiting and the excess reactant for a reaction. So just to review where we are, at this point I've introduced stoichiometry to you, which means you understand that there is a mole ratio. A mole ratio is a relationship established between two given substances within a chemical equation, okay? And it is essentially the coefficients. So given this particular equation, it's that the ratio between chemicals in this equation is 2 sodium hydroxide per 1 iron chloride makes 1 iron hydroxide and 2 sodium chlorides. So if you're asked the question, how many grams of sodium chloride is made from some number of grams of the reactant, what you're going to have to do is convert to the mole in order to use a mole ratio to get to moles of a new thing, and then from there you go to grams of your new product. So again, it's that basic stoichiometry problem of taking grams of a substance, getting it to mole by using the molar mass of your substance. In this case, it's sodium hydroxide. Okay? And once you get that, then you use a mole ratio, which is a ratio between their coefficients as given to you in the chemical equation, to go from one thing to a new thing. So from sodium hydroxide, which is a toxic base that upon contact will burn your hands, to sodium chloride, which is something in all your food. And then once we're in moles of sodium chloride, we can go from moles of sodium chloride to grams, again using your periodic table. So this is the definition of stoichiometry, given the fact that that establishes your mole ratio. What that whole conversation does not talk about is the fact that in practicality, we are going to have probably two reactants being mixed together. Okay? The problem I just looked at is one where, given a certain amount of reactant, I can predict how much product is made from that. But the problem is there are two reactants, and the question becomes, well, how much of the other reactant I have, and does that limit my production? So here's a general problem. Okay, I have 4 slices of bread, a jar of peanut butter, and a jar of jelly. The recipe for me to make a peanut butter and jelly is that I need 2 slices of bread, a tablespoon of peanut butter, and 1.5 teaspoons of jelly. So given that's my recipe, I look at all my reactants, the bread, the peanut butter, and the jelly, and I ask myself, how many sandwiches can I make? Well, I only have 4 slices of bread, so I'm only going to have to be able to make 2 sandwiches from the bread. I have a whole jar of peanut butter, and with the 1 tablespoon of peanut butter per sandwich, I'm probably going to have a good, 10 to 20 peanut butter and jelly sandwiches from that, depending on the size of the peanut butter jar. I have a whole jar of jelly, and again, with 1.5 teaspoons of jelly, I'm going to be up again in the 10 to 20 sandwiches available from that jelly. So the bread limits me to 2, my peanut butter and my jelly allow me to do 10 to 20. I won't be able to make 10 to 20 because I don't have enough bread. So in this problem, my limiting reactant in terms of my production would be my bread. And I'm unable to make 20 sandwiches because I don't have bread. After I make 2, I'll be done. That is the culmination of a stoichiometry problem. The fact that you need information about all things being mixed together in order to determine what's being made, because it's not a complete picture when we predict product based on one. If I told you how to jar of jelly, you could predict how many sandwiches you would make. But you would need the other reactants to make the recipe happen. So that is the concept of limiting reagent. Okay, when we have more than one reactant, you are unable to get perfect stoichiometric amounts to make them all disappear. Okay, it's very rarely we're in a perfect world where you use all of your recipe to make your product, where you run out of all of your sandwich making ingredients to make that last sandwich. Generally, we are going to have one in excess, which means one that there's just too much of, one that I have left over once the recipe has been mixed. And then I have something called a limiting reagent, which is the thing that limits my production. When we think about that chocolate chip cookie recipe and think about what we run out of first, generally speaking for me, I'm going to run out of my chocolate chips because per 1 package, I can make 1 recipe. Where my baking soda, my baking powder, I could make probably that recipe 10 times over. But I couldn't do the recipe 10 times over unless I had 10 bags of chocolate chips. And if I only have one, then that is my limiting reagent. And the stuff that's left over, that's an excess, the stuff that I have to clean up and put away at the end and put it back into my cupboard. What a limiting reaction problem looks like is just like that stoichiometry problem I started with, except for one big component. I have two numbers, not one. Generally speaking, we've done problems where you're given one value, and that one value is converted to a new one. In a limiting reaction problem, you need to do more thinking. The thinking that's required is the fact that you have two starting values. It's a real-life situation. I have 4 moles of aluminum and 6 moles of chlorine gas that I'm mixing together. And the question is, how much can they make? Here's the chemical reaction that's used. Let's look at how this problem's set up. Here's the chemical equation for this particular reaction. We can look at the equation and see how we have a 2 to 3 to 2 mole relationship, right? If I have 2 moles of aluminum, I'm going to make 2 moles of aluminum chloride. If I have 3 moles of chlorine, I'm going to make 2 moles of aluminum chloride. So the question is, now, in this problem, I don't have 2 moles and 3 moles. Instead, I have 4.14 moles and 6.17 moles. From that, you know that if I put 4.14 moles in, I'm going to make 4.14 moles out. If I put 6.7 moles in, I'm going to make 3/2 of that if you set up your mole ratio. Okay. The question becomes, can I make that 4.14, or do I only make 3/2 of this? So let me set up my math so I can show you what I'm talking about. So if I look at this now and I set up my mole ratios appropriately, I can convert 4.14 moles of aluminum to moles of aluminum chloride, and I convert moles of chlorine to moles of aluminum chloride. If I do this top one, we already said, I'll get 4.14 moles of aluminum chloride. If I do this bottom one, I will get 4.11 moles of aluminum chloride. What that means is, if I put 4.14 in, I can get 4.14 out. But if I put 6.17 in of this reactant, I can only get 4.11 out. It's just like the peanut butter and jelly example. Okay. If I have a whole jar of peanut butter, I can make 20 sandwiches. But with only 4 slices of bread, I can make 2. With this amount of aluminum, I can make 4.14. But I can't make 4.14 because my chlorine limits me. It's my limiting factor. I can only make 4.11 moles based on the chlorine. The chlorine will run out. One of my reactants is gone. And once the reactant is gone, the reaction will stop. And I'll only have 4.11 moles of aluminum chloride. If I were to put more chlorine in, the reaction would start again. Okay. So this video is not going to go super in-depth on the math. We'll do that in class. But what I want you to get here is the concept. The concept that when you have multiple reactants, right, one of them eventually is going to run out and you will stop. If you were making bicycles and you had bicycle parts, you had the seat, you had the handlebar, and you had the wheels. At one point, one of those components is going to run out, and that will be your limiting factor. In this case, my chlorine runs out first, because once I get to 4.11 moles, once all of this is used and 4.11 moles has been made, I stop. I can't make the 4.14. I can't make a bike with only wheels. I need the handlebars and I need the seat. I can't make a peanut butter and jelly sandwich without the bread. I need that bread to make it. So that's a general concept. Why don't you go ahead and do the form, and we'll go more in depth on the math tomorrow.